Hi all. Now we will discuss on as an extension to the last video how to solve a second order differential equations. Second equations are particularly important in physics because we also have the equations like F is equal to force equations are there. The force equation have m into d square x by dt square. If we solve this, we can solve a lot of problems. Okay, that's why second order differential equations are very important. So in this video we'll try to solve how a second order equation can be solved. Okay, let's do an example. This is an equation which is called d square by dx square minus 4 into dy by dx plus 5y is equal to 0. This is homogeneous equation because the right side is 0. So then how to solve it? So this is a step which we can solve a second order equation. Homogeneous equation. Okay, so this is our equation d square by dx square minus 4 and dy by dx plus 5y is equal to 0. What you're doing is you have to replace the differentials. This is called d square by dx square. You can replace by d square and dy by dx by 4d. Then your equations become d square minus 4d plus 5 is equal into y is equal to 0. Okay, then what you're doing is you have to write an equation called auxiliary equations. Auxiliary equation is nothing but you can replace d with the m and write an equation only this term. Okay, m square minus 4m plus 5 is equal to 0. Then what you can be doing is you can solve these quadratic equations. So you can rearrange these equations. So you can use different methods. Either you can use this equation minus b plus or minus root of b square minus 4ac by 2a, or you can factorize these equations to get the solutions of m. So I can do this m minus 2 all square minus 4 plus 5 is equal to 0. Then m minus 2 all square is equal to minus 1. Then m minus 2 is equal to plus or minus root I minus 1. Then if I solve this one, I get a m is equal to 2 plus or minus I. This particular case I am getting an imaginary number. There is a possibility that it may be a real number. Maybe both the numbers are equal or distinct. So according to the different possibilities, there's a table. We can use the result directly. So if the roots are only one real root m1, then the solution is directly c1 e raised to m1x. Then the other possibility is two real and different roots m1 and m2. This is, you can write it as c1 e raised to m1x plus c2 e raised to m2x. Then other possibilities, you can use three roots. Then you can extend to one more term. And other possibilities are two real and equal roots m1 and m2. The roots are equal. Then you can use c1 plus c2x e raised to m1x. And the other possibility is there is a complex root. A pair of complex root may become. This is called alpha plus or minus I beta. That what is observed in our example. Then the solution is e raised to alpha x. Alpha is the first term. Then c1 cos beta x. c1 is a constant. Beta is the second term of this complex number, and c2 sin beta x. Okay, like that we can also do the one pair of set root alpha plus or minus root of beta, etc. You can look at the solutions and we can directly substitute this equation. Okay, these are very important. One is real distinct, real equal, and these are complex roots. Okay, so from our observation we can find that this is our solution. Then I can from this we have alpha is 2 and our beta is 1. So I can substitute this value e raised to alpha instead of alpha equal to 2, then a cos beta I put 1 and plus b sin beta x again 1. Okay, so that's why this is the solution. This is a complementary solution. Then the general solution is e raised to, that's actually a complementary function. The solution itself is a complementary function, that is e raised to 2x a cos x plus b sin x. So that's why simple homogeneous differential equations can be solved using this complementary function, and we get the solution. Okay, so I tell that this is a very simple equation. A linear homogeneous second order equation is very simple. There is a possibility that it may be non-linear and it can be extended. such case it's very difficult to solve the problem. Okay, as this picture shows, if you get any ordinary differential equations, whether it is solved or not, we have to look at different conditions and to use the suitable tricks to solve this. Okay, that's why there may be possibility that this linear, there's different options like we can use Laplace transform, variation of parameters, etc. to determine. Okay, these are the different analytical methods we can do. So there is a method called numerical methods, where we use some approximations to the solutions, and the numerical method have an is particularly useful when you are trying to solve some complex differential equations. It will give a nice results for that one. So the main use of numerical analysis is to solve differential equations which is not solved exactly using the these analytical techniques.